My name is Rila Dinesh from CSITA section. My video concept of a basic electrical engineering is how to find equivalent Thevenin voltage source and relating problems. Let's discuss. Okay. Index. First theorem developed by Thevenin's equivalent circuit explanation, Thevenin's voltage, Thevenin resistance. My Thevenin's theorem is not applicable to nonlinear circuits. Can Thevenin's theorem be applied to a circuit AC source? Why Thevenin's equivalent circuit is not very useful? Microwave frequency applications, advantages and limitations. Okay, now see what is theorem. Thevenin's theorem states that any linear circuits containing several voltage source, resistor source can be replaced by just a single voltage in series with a single resistance connected across the load. Who developed this Thevenin's theorem? A guy. He born in 1883. The theorem was developed by Leon Charles Thevenin, an electrical engineer with the France National Post at telecommunication organization. Okay, this guy was prepared at Thevenin's theorem. Okay, Thevenin's equivalent circuit. Here RL represents the load resistors across V, where we must find the Thevenin circuit, voltage Thevenin's and resistance Thevenin's. A linear network containing several EMF and resistance is known as a load resistance, where it is denoted by RL. Here, step 1 explanation. Step 1, the Thevenin statement is explained with the help of a circuit shown in below. Voltage source, resistance, resistors are R1, R2, R3, R4. Where R1, R2, R3 are the resistor, where we were not finding any load resistor. Just we are finding the load resistor at RL, where current is decreasing, current is going downwards or decreasing. Step 2, we must apply mesh analysis. Thevenin's theorem has some conditions where to find out if we are finding any load resistance across any resistor, that must be an open circuit, and voltage source must be short circuit, and ammeter also open circuit in some conditions only. Suppose we must calculate the RThevenin's. The voltage source will be short circuited and open circuit will be a ammeter, and the given the across the load resistor we must finding it must be an open circuit. Like this, some conditions will be there to find out to calculate the circuit. Okay, step 2, we are applying here this OC represents the voltage Thevenin's or voltage open circuited. Here A, B are the two terminals open circuited. In open circuit the current will be not passed. That's why we are leaving these R2 resistors. And in the first loop I direction we are applying mesh analysis, where V open circuit is equals to I, V is equals to IR according to the Ohm's law. V is equals to IR. We are finding here I, where load resistance parallel to R3, if we find the voltage across R3, it is same to the load resistors, opposite, because it is opposite to R3. Here it is a formula. Here I am zooming. V open circuit is equals to I into R3 is nothing but Ohm's law, where I can be written as V S into R1 plus R3. Given resistor to opposite resistor according to the parallel division rule. Okay, it is step 3. R1, R2, R3, the R Thevenin's is in the opposite direction. So R Thevenin's here, I told that voltage circuit is short circuited and here ammeter is not present. That's why we are not we are not putting any open circuited. And across we are finding the road resistor that will open circuit only. So R Thevenin here R1 R3 are the this R1 will shifted to here. R1 will be shifted to here. R1 will shifted to here because it will be short circuited. This shifted to here. This R1 is parallel to R3. R3. R3 is connected in series. So here R2 is connected in series. Here in bottom of the PPT we are seen R3 R Thevenin equals to R2 plus R1 R3 are the parallel. The parallel formula is R1 into R3 but divided by R1 plus R3. Okay. Now we will see step 4. After from VThevenin's we will find VThevenin's. We will find current across that and R Thevenin's is R Thevenin's here and this is loss Thevenin's. As we discuss, according to that statement, according to the Thevenin statement, the R Thevenin must be connected in series with a load resistance, have a single voltage source. Yeah, applying here. Okay. Now we will discuss about the Thevenin's voltage. Thevenin's voltage E is equals to V1 R3 R1 plus R3. Very in this circuit you can see V is equals to like this, open circuited and loop. Okay. The Thevenin voltage is open circuited voltage at the terminal A and B. This Thevenin's resistance R is the resistance seen at AB, which voltage source replaced by a short circuited and all current source replaced by open circuited. Thevenin's equivalent circuit. Okay, now we will see Thevenin's resistor. Thevenin resistance. Thevenin's resistor here R1, R2, R3 voltage source are short circuited and open sources VAB is open circuited because it is a load resistor where R is equals to where R1, R3 are the parallel and R2 is connected in series. Then R1 R formula for parallel circuit for parallel is parallel connection is R1 into R3 divided by R1 plus R3. If they are both are connected in series, then R1 plus R2 is, that's it. Okay. Now we will see why the Thevenin's are not applicable in non-linear circuits. Thevenin theorem can be used in non-linear circuits, cannot be used in as long as it is used at linear or approx linear parts of curve. For example, let's look at common emitters. Common emitter here you can see that road here open circuited there. Okay. Can Thevenin's theorem can be applied to a short circuit have a source? Yes, Thevenin's theorem is applied in both AC and DC sources. Like this circuited here replaced the sources AC source and DC source replaced resistor. That's it, same process. Okay, application. To determine the change in load voltage, to predict a range of a load voltage, variations of change in load resistance, to obtain Norton equivalent circuit, to determine the maximum power that can be transferred to a load from network, source modeling and resistance measurement. Used the Wheatstone bridge provided applications of Thevenin theorem. This help in making the integrated circuits. Okay, now we will jump into the problems here. Problems. Okay, here 6 ohms. R1 is 6 ohms. R4, R2 is R3 and R4 voltage is 20. Then load resistance will be here. IL is a load resistance, means uh, 2 ohms will be open circuited here. See here. First step, 2 ohms resistor is open circuited. We must, because we must find across that load resistance AB terminal. Here it is see here 6 ohms R1, R2, R3 is a 5 ohms. R2 is open resistor, load resistor. That's why are open circuited. Let's see step 2. Find the Thevenin voltage with A minus A to B. Thevenin voltage is not voltage across the Thevenin A and B equal to the amount of algebra which fills the resistor voltage at 4 ohms and 5 ohms. To find the voltage dropped on the both resistor, looking for to further advance Ohm's law using circuited multiplier and resistance. In addition, the voltage drop off on both the resistors can be also found using the Thevenin voltage dividing. This test is mostly based on the Ohm's law only. Okay, calculation of VThevenins. For VThevenins, we must open circuited also here. For VThevenins, we must have here. You can see the 4 and 6 are parallel. No, 6 is an open circuited and 4 and 5 are the series. So V is equals to, here I will write better. V I is equals to V by R. V by R. See here, V by R. V by R, where V is a 20 and R is a 4 and 5, because 6 is an open circuited, there the current will does not flow there. Then 4 plus 5 is 9. 20 divided by 9 is 11.111. 11.1111 like that. We can put an approx as a 12 voltage. Okay, it's done here. Now step 3, find the Thevenin resistance. Short circuited the power supply. Here we must find the RThevenin. In RThevenin we must short circuited a voltage source by short circuited. Now this 6 will be transformed here because it is short circuited. Then it is parallel. Then it is parallel. Then these are connected in series. Then 4 plus 5 is 9. It is parallel to this. So 9 into 6 6 plus divided by 6 plus 9. 9 into 6 44 divided by 15. Then 3.60 is the Thevenin's resistor or resistance of a Thevenin's or Thevenin's, where finally draw the Thevenin circuited equivalent circuit where R Thevenin is seriously connected series with RL load resistor, where V Thevenin we got it as 11.5, we put it an approx 12 volts. Then finally we are calculating the I Thevenin, where I is equals to, by according to the Ohm's law, I is equals to V by R, where V is equals to 12, when R, they are 2 R. Here we are having 2 resistors, means we must do sum of these. Okay. Then 12 divided by 6.6, 3.6 plus 2, where it is 12 divided by 5.6, where answer is 2.143 amperes, where current is measured in amperes, so the unit is ampere. Like this we can find the RThevenins. Okay, thank you, have a nice day.